Come on. There's the fuel going in now. Gas is off. Starter motor is off. Okay, it's just gone at 34,000 is idling now. And that's basically all it does. So with any gas turbine, the only way to stop it is actually just turn the fuel off. And so it actually shuts down at full operating temperature. And as you notice there, I actually turned the fuel off whilst it was at a fairly high throttle setting, midpoint. And so as it spooled down, it has sucked in a lot of cold air to help cool that turbine down. The starter motor has now started again and is now pulsing the rotor over, just sucking a bit more cold air until it gets down to 100 degrees, which we're nearly there. It's already 106, so any second that will stop. So that's our turbojet. So very noisy, great machine. So now we'll move across to the turbo shaft. Sorry, yes?
What sort of bearings are you using there?
Bearings, they're basically ball races, but marginally unusual ones. We have standard steel races, inner and outer, but we have ceramic balls and no cages.
No.
So the correct title is full complement angular contact hybrid ball races.
Right. Incredible.
Including lubricant?
Including lubricant, we actually run, it sounds a bit peculiar, but these are two-stroke essentially. We actually add a bit of oil to the fuel, which goes through a gear pump which pressurizes it in order to introduce it to the combustion chamber. But we have a little T-junction and a restrictor, so a tiny quantity of that mix gets dripped just behind the compressor but in front of the front bearing. And as it touches the shaft, each drip just goes into an atomized spray, and we bleed some of the air off the compressor, and that goes as an oily mist through the whole shaft tunnel, through both bearings, and is burned off on the way out. And to give you some idea of the effectiveness of that, as I said, there's 850 degrees going into the turbine, and the rear bearing is about 10 millimeters away from that hot gas flow. So even though it's not in the gas flow, there's a lot of radiant heat coming inwards, you know, all the way around it. But that cooling, vaporizing, oiling mist going through it, that rear bearing doesn't exceed 140 degrees. And those bearings are actually, they're manufactured and they're guaranteed for 160 at 300 degrees. So we're using them at a very modest level. Right, let's have a go with the helicopter. What you'll see when I spoke earlier about no mechanical connection, there you see the gas has started. The rotor's not moving, yet the engine is. Not again. Is it still trying? Sometimes we find, which is why I had this gas bottle in my pocket earlier, as temperatures go down, butane propane mix, the actual storage pressure reduces, so you sometimes don't get enough flow out, and what's happened there is the gas is blown out before the kerosene has managed to get up to temperature. So it's actually just temporarily shut down. Again, it's an automatic reaction of the controller. So what's happening now is now go through a cooling cycle, much like my one just went through, just to bring the temperature below 100 degrees. It will then have another go with, you know, the gas will then relight and it'll probably go up on the second occasion, but slightly embarrassing when it doesn't do it first time. They are a commercial control unit, but the guy who does it or makes them and sells them is a former member. So yeah, he used to make them amongst them, but we then got a lot of people who love to fly but didn't have the facilities to make one themselves. So commercial engines became available. So you needed the controllers as well. So it became a little bit of an industry by itself. We advocate doing it yourself. There's greater satisfaction in something you've done yourself, but sometimes you just don't have the facilities available to you. But one of these, I built this on a standard Myford Super 7, no milling machine, all milling operations done on vertical slide, etc. So you don't need much to make one, as long as a lathe is fundamentally your main tool. But yep, most things, if you have go out and buy one, you probably nowadays it'll cost you won't get much change out of £2,000, but I would advocate making it yourself for about 400. How are we doing?
I don't know, I don't want to know. It's still too hot.
Still too hot, is it? Slowing out again, is it? It's going. Okay, we're getting there. Okay, we're on idle, lads. The gas turbine is now running about 42,000 RPM, and you can see the steam turbine just taking over. And that's all it does. It obviously does a lot more when it's got blades on it. But the reason for the nice yellow balls on the head